I am Dr. K. Misra from our classes. I hope all of you are doing good. Today I am to talk about theoretical view of network analysis, that is obviously CPM and PERT. Prior to start my discussion on this particular presentation, I must remind you of my previous video tutorials which I have sent to you through my YouTube channel on network analysis, construction of network, CPM, that is determination of critical path, determination of floats, PERT analysis, and crashing of the project. Today, as I told you, that I am going to take up the theoretical view of network analysis. Here in my presentation, I will include specifically what is network or network analysis, basic terminology, CPM and PERT, rules for constructing network floats, and the CPM and PERT more other aspects. Network analysis. Network analysis plays an important role in managing a project. By analyzing a network, which is basically a graphic depiction of activities, events, planning, scheduling, and controlling of a project, that makes it more easier. Program evaluation and review technique and critical path method represent the two well-known network analysis techniques used to assist the managers in planning and controlling the large construction projects, research and development, and so forth. Now, as far as network is concerned, so in my previous video tutorials, also I have made it clear that network is basically a technique used for planning and scheduling of large projects in the fields of construction, maintenance, fabrication, purchasing, computer system, and other different fields. Actually, this subject is of utmost importance for those who are in such fields, and specifically for the students, whether they are pursuing MBA or MTech students or other those who are involved in such disciplines. So network analysis requires certain considerations that we need to look into much of its detail. There is multitude of operations research situations that can be modeled, solved as a network. Some recent surveys reports that many of the real world mathematical programming problems can be represented by network related models. So such pieces of information increase the importance of network and network analysis. My dear viewers, now I am going to talk about basic terminology. Herein, a network, as it has been already made clear, that it is just a graphical representation of logical and sequentially connected activities and events of a project. Network is also called arrow diagram, that we have seen in our previous you know video tutorials. Another term normally we use as to what is a project or what is the project management process. So a project is defined as combination of interrelated activities which must be executed in a certain order in for its completion. A project can be viewed as a set of activities or jobs that are performed in a certain sequence determined logically or technologically. Therefore, the initial steps in CPM and PERT project scheduling process is the determination of all specific activities that comprise the project and their interdependence relationship. A kind of precedence or successor succeeding events exist in a network. Project management process, network analysis is the general name given to certain specific techniques which can be used for the planning, management, and control of projects. Activity. So, here any activity normally which is represented by an arrow that has its head and its tail. Head is normally referring to the completion of that activity, and tail of the activity refers to the starting of that activity. Any individual operation which utilizes resources and has an end and a beginning is called activity. It may be a task, certain amount of work in a project. As I told you that it is represented by an arrow. These may be predecessor activity, successor activity, concurrent activity, and dummy activity. Normally, dummy activity is no activity, rather it is it just represents that activity just to connect the network. It hardly has any its initial or ending, starting or ending point. It only indicates the precedence relationships and does not require any time of effort. Program evaluation and review technique was developed and used in conjunction with the planning and designing of the Polaris submarine system. It was credited with saving substantial time and cost on Polaris, which caused its use to be made mandatory on all the significant projects undertaken for and on behalf of the Department of Defense of the United States. It is a method to analyze the involved tasks in completing a given project, especially the time needed to complete each task and identifying the minimum time needed to complete the total project. PERT is based on the assumption that an activity's duration follows a probability distribution instead of being a single value. Here, in cases of the projects where the completion time of an activity is not certain, normally we apply PERT. Three types of timings are observed here. One is pessimistic time that has got a symbol, say A or TP. That is the time of the activity would take if things did not go well. Most likely time or most likelihood time, that is normally represented by M or TM here as being shown, that is the consensus best estimate of the activity's duration. Optimistic time, normally say TO or say by B, the time of activity would take if things did go well. Certain formulae we also use in order to calculate expected time, that is also known as mean. So here we write it as Tp minus 4Tm plus T0 upon 6, or any other notation like in different books. It is written as A plus 4M plus B by 6, where A, that is most optimistic time, M most likelihood time, and B most pessimistic time. Since it involves probabilistic calculation, so we need to calculate variance, that is basically B minus A by 6 or Tp minus T0 by 6 whole square, and then through normal distribution variate, that is Z is equal to x minus mu by sigma, we can calculate whether a particular project can be completed in a given period of time. What will be the probability of that? Let me tell you that practical problems on this particular topic, say PERT, I have already solved and uh, sent it to you people through my YouTube channel. You may like to watch the same on my YouTube channel, our classes. Now let us talk about critical path method, that is CPM. Here historical background to it, that it was developed by DuPont Company and the Univac division of Remington Rand Corporation as a device to control the maintenance of chemical plants. While both PERT and CPM have similarities in terms of concepts and methodology, a basic difference exists between the two techniques. PERT is useful for analyzing project scheduling problems in which the completion time of the different activities and therefore the whole project is not certain. Sorry, here it is completion time of the activities. CPM is most appropriately used in projects in which the activity durations are known with certainty. The question is where to apply CPM and PERT. This is something which, if you don't have very clear concept about the topic, you won't be able to decide where to apply CPM and PERT, or in what situations these techniques alternatively are applied. So one basic difference I have already given you, that in cases where time is not certain, we apply PERT, and where time is certain, we apply CPM. Both techniques are useful for any situations where the 3 points are satisfied. First, the project consists of well-defined collection of activities or tasks. Second, the activities can be started and terminated independently of each other, even if the resources employed on the various activities are not independent. The activities are ordered third so that they can be performed in a technological sequence. Thus, precedence relationship exists which preclude the start of certain activities until others are completed. Now, there is a set of certain rules for constructing the network. Here I have tried to put it in at one go so that it becomes easier for you to understand. First, that each activity must be represented by an arrow. Second, before an activity undertaken, all activities preceding it must be completed. Third, the arrow head represents the point in time at which the activity completion event takes place, while the arrow tail represents the point in time at which the event activity occurs. Fourth, when a number of activities terminate at one event, it indicates that no activity emanating from that event may start unless all activities terminating there have been completed. Events are identified by numbers. An effort should be made to have each event identified by a number higher than that allotted to the event immediately preceding. In assigning numbers to the events, care should be taken that there is no duplication of event numbers in a network. The activities are identified by the numbers of their starting and the ending events. Seventh, a network should have only one initial and one terminal node. 8. An event which represents the joint completion of more than one activity is known as a merging event or merge event, while an event which portrays the initiation of more than one activity is called burst event. Last, that is ninth of my this presentation as far as rules are concerned. So here ninth one is parallel activities between two events without intervening events are prohibited. Thus, two or more activities cannot be identified by the same beginning and ending events. By implication, any two events should not be directly connected with more than one arrow. When two or more parallel activities in a project have the same head and tail event, dummy activities are needed in constructing the network. Moreover, I have already explained this in my previous video tutorials specifically on networking. So here, as in the start of my presentation on this particular topic, I told you that I would just be covering the theoretical view of the topic. Next, there are certain situations. Here it is shown through symbols, like first, activity A must finish before B or C can start. In second case, both A and B must finish before C can start. In third case, both A and C must finish before either of B or D can start. A must finish before B can start. Both A and C must finish before D can start. So these are shown through the symbols here. Now another important aspect which I have already covered in my previous video tutorials and shown the how to determine the floats. So here theoretical view of floats. What is float basically? What is the conceptual framework behind it? So since the critical activities cannot be scheduled later than their earliest scheduled time without delaying the project duration, they don't exhibit any flexibility in scheduling. However, while exercising control over time, resources or cost, it is necessary to know as to what flexibility exists for scheduling the non-critical activity of the project. The flexibility is seen in terms of the float or slack that any activity has. The critical activities have no floats. Let me make you it very clear. Work on only non-critical activities, on the other hand, may be postponed for some time without affecting the project. Types of floats. 1. There are basically 4 types of floats. 1. Total float. What is total float? So total float of an activity represents the amount of time by which it can be delayed without delaying the project completion date. Here is a formula that is written that we have practiced it. Latest finish time minus earliest finish time, or latest start time minus earliest start time, or latest finish time minus earliest start time minus duration of the activity. Second is interfering float. The part of the float, total float, which causes a reduction in the float of a successor activity is called interfering float. That is equal to difference between latest finish time of the activity in question and the earliest start time of the following activity, or 0, whichever is longer. Third, free float. Free float is that part of the total float which can be used without affecting the float of the succeeding activity. We can calculate it by taking the difference, subtracting interfering float from total float. Independent float, it is the float time of an activity is the amount of float time which can be used without affecting either the head or the tail events. Even independent float is equal to earliest start time for the following activity minus latest finish time of the preceding activity minus duration of the present activity. Difference between CPM and PERT. Some already I had explained to you here. PERT is event oriented, CPM is activity oriented. PERT is probabilistic. CPM is deterministic. PERT is primarily concerned with the time only. CPM places dual emphasis on project time as well cost. PERT is generally used for projects where time required to complete the activities is not known a priori. Thus, PERT is used for large and R&D type projects. CPM is used for projects which are repetitive in nature and comparatively small in size. Three type time estimates are possible for activities linking up to two events in PERT. In case of CPM, one time estimate is possible for activities. No allowance is made for uncertainty. That's how we have completed this theoretical view of the topic. I hope that all of you have liked it, and if you have liked it, so kindly like it, share it, and subscribe it. Thank you very much. Have a nice time. Thank you.